Hello guys and welcome back. Today we are continuing with our 100-day JEE Advanced question series. And guys, the question you right now see on screen, that is from a book which is like made for Olympiads, but some questions are really relevant to JEE Advanced, so I thought I should bring them in. Like, I will tell you the name of the book, but don't try to like solve all the sums, okay? Because it's basically for Olympiads. Like, there are many proof type sums, some sums based on mathematical induction and all, okay? So you are not supposed to do all that. And the name of the book anyways is Math Storm Olympiad Problems. It is written by Rajiv Rastogi and Daniel Sitaru. Okay, you can find it somewhere. I guess you will get the PDF. Anyways, like this book contains really good problems. Okay, so I will try to bring many of them in this series in the next couple of days. So guys, the question that you right now see on screen, I hope it's visible. So this question will have a long answer, so I will just add on one single line, okay? And that line is if. Like you can see, the question is asking us for the value of ohm. Okay, so if ohm is equal to m plus of e power p by q, then the value of m plus p plus q is equal to, okay. Like I converted this into a numerical type sum. The answer will be something of this sort. I converted into a numerical type, but anyways, they can give you as an MCQ correct also. Okay, this can come in your single correct option type too. Anyways, guys, that's all, and you may try out the question right now if you want. I will wait for a few seconds. You may pause the video, and then afterwards I will start solving. Okay, guys, so I hope you have tried out. So what I am doing is I will right now maybe move on to the next page because there is no space here. Okay. And I hope, okay, let's write down some data. First data that is given is your f of x plus of f of 3 by 5x is equal to x. A functional equation is given and this is continuous at your x equals to 0. And one more thing is given, that your g of x is equal to limit n tends to infinity sigma n equals to 1 to n. Okay, actually guys, this thing is written as sigma n equals to 1 to n. If you want, you can write it out as r equals to 1 to n, but anyways, whatever is given in the question, I am writing it. Okay, though the two variables being same is not very correct, I guess. Maybe it's a typing error or something. Okay, anyways, this will be 3 power n minus 1 sine cube x by 3 power n. Like you understood what I said, right? This actually should be r equals to 1 to n, and this complete expression should be in r. But because they have given it in terms of n, so we are writing it like that. Okay, let's not go against what is written in the question. So guys, right now I will change the screen and then start solving. Okay, so information that is given is in front of us. So guys, right now what I am going to do is I will put f of, like, in place of x, I will put 0 everywhere in this equation. So if you do that, I guess very simply you will get f of 0 as equal to 0. Okay. Now, like, to solve this particular thing, I am applying a very interesting trick here. Okay. Like, this is something that JEE Advanced hasn't still used. Actually, this is supposed to be part of your mathematical induction. If you like, it's not in your syllabus anymore. If you had done mathematical induction, it's mostly a proof based chapter. When our IIT JEE was subjective type, then actually mathematical induction was one of the most difficult chapters, because then there were a lot of proofs and all. Okay, anyways, you don't need knowledge of that, but just see what I am doing right now, because this idea is something that JEE Advanced hasn't still used and will maybe use in the coming years. So guys, what I am going to do is I will take this functional equation. Like, basically I am trying to frame f of x. Okay, I am trying to frame f of x in terms of n. And why, you will notice that after a few moments. So guys, what I'm doing is I will write f of x is equal to, like, very plain simply, I will just take this to the right hand side. So this will be minus f of 3 by 5 x plus x. Okay. Now this is like the changed equation, but one thing that you guys should notice is, once again, if I take this equation and from here if I try to write down one thing that I'm writing. So basically what I am going to do is I will write minus f of x as equal to f of 3 by 5x minus x. Okay, now just see what I am doing. In this particular equation, in place of x here, I am going to substitute 3 by 5x. Okay, so this thing will become minus f of 3 by 5x equals to f of 3 by 5 whole square x. Okay, minus of 3 by 5x. So now if we go and backtrack this into this particular equation, then we will get minus f of, I'm sorry, not minus f of, this will be your plus f of 3 by 5 whole square into x minus 3 by 5x plus x. Okay, and in a very similar way, if I once again take your 3 by 5 whole square and, like, here in place of x again in this equation, if I substitute x with 3 by 5 whole squared x, okay, then I will get another similar equation. I will then substitute again into this. Like, you can understand, right? A repetitive sort of pattern is coming. I hope you can understand. I'm not going into the further steps. I'm repeating it once again if you didn't. Like, you can see this, right? F of 3 by 5 whole square x. What I am going to do is I will backtrack this into this particular equation and then find the value like we did like this. Okay. It will be actually a very repetitive sort of process. That is actually what we did in induction, but I have to explain because it's not in your syllabus anymore. Okay. I hope you have understood this part. So what I will do is I will write down the final expression for you guys and see, like, I didn't go into the explanation, or I will just repeat it for you one last time. Okay. Okay, let's do one thing. I am writing down the final form, then actually you will understand what is happening because that will be much easier for you to understand. Okay. The final form of this thing that will actually come, actually f of x will then be expressed as a polynomial. Okay. Just see this. F of x, like, if you, whatever I did in the first step, we will just repeat that, okay, till n terms, because we want to find this in terms of n. So if I repeat that till n terms, what will actually come is f of x will come out to be minus 1 power n. Minus 1 power n, why? Because you saw in the first step we had minus f of 3 by 5x. In the next one you will have f of 3 by 5 whole square x. In the next one you will have minus f of 3 by 5 whole cube x, and this pattern will continue. Okay. So this will actually be, first term will be minus 1 power n f of 3 by 5 whole power n x. After that you will have minus of 1 power n minus 1 3 by 5 power n minus 1 times x. Like, actually you can understand the pattern, right? If I show you the first term here once again, then you will see the first term look like this. Actually there will be only one term that will contain f in this particular polynomial expression. Okay, rest of all the terms will be in terms of 3 by 5 minus 1 and x. You can observe that. Like, if I want to write down the next term in this series, then the next term will be something like this. Plus of minus 1 power n minus 2, 3 by 5 power of n minus 2 into x, and so on. Okay. And this will go on till dot 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 your 3 by 5x plus of x. Like, you can understand one thing from here. Okay, sorry, not plus, this is minus. One thing that you can understand is if you notice this particular part, right? If you notice this particular part and just do a very small comparison with our first expression, you will see this part is actually remaining constant, which means that this particular f of something into x expression will actually keep on updating to the next higher power. This will become f of 3 by 5 whole cube, f of 3 by 5 power 4, 3 by 5 power 5, and so on. This will keep on updating, and each time it updates, terms will get extra terms will get added. Okay, like I guess with each term of the power, each power increasing, there will be one term addition. This was like minus 3 by 5x plus x two terms because plus x was already present here. But with each increment in the power, one term will get added each time. So actually, I guess this f of x right now, it contains n plus 1 number of terms. Okay. If you just add this x here, it will contain n plus 1 number of terms. Yeah. Like this is your 3 by 5 x power 1, and this is still n. So 1 to n is n terms, and this one term will give n plus 1 terms. Okay, this thing is really important. I hope you have understood this still here. Okay, I tried my best to explain because it's actually very difficult to explain it on a video. If I had explained this to you offline, maybe it would be better. Anyways, guys, I hope this is clear. Okay, each time the power, like it starts from your way down to your first step we did, f of 3 by 5 whole square into x, and f of your 3 by 5 whole square x, and then with each power increment, one term extra gets added on, and that's why you have all these terms here. Like because of this power n, this term is added. Before that one, when this was f of 3 by 5 power n minus 1 only present, not n present, then this term would be added. Okay, like very basic thing. With each power increment, one term will be added into the expression, and finally you would have only one f term remaining. Okay, I tried my best to explain. I hope this was clear till here. Okay guys, so let's proceed. I hope you have understood this. So right now, like this is our f of x overall, what we have got from our manipulation. Okay, so right now after this step, what I am going to do is, because if you actually notice our question, right, the question had g of x by f cube x one term, and another term was 1 plus g of x power of 1 by f cube x, and both were limit of x is tending to 0. And because g of x has limit n is tending to infinity, so I guess it would not be a bad idea if we also find this sum to not n terms but till infinite terms. Okay, that would actually be more convenient, because already if g of x has n tending to infinity and we are processing g of x with f of x, I hope we can tend this sum to infinity also, because even the continuity condition is applying at x equal to 0, right? It's already given. So my idea is, let's take your n is tending to infinity, like you can say limit n is tending to infinity f of x. You can easily say that. And we also know that f of 0 is equal to 0, and also continuity condition is being fulfilled. Okay, so if we try to apply these things, then your f of x would come out to be equal to x. Like you can understand, right? I am applying limit n is tending to infinity. So right now if you see, like because your highest term in this particular expression, we will not play with this f much, but if we see the highest term in the open x terms, it is actually 3 by 5 power n minus 1, I guess. Okay, so like see here, you can do two things. Either you take the highest power and whatever you do with limit n tends to infinity, do that, or I guess that would be little messy. So better is you just reverse this particular expression. Okay, write this from x minus 3 by 5x. So if I do that, it will be x minus 3 by 5x, and obviously you know it's a minus 1 power n minus 1. So actually your plus minus would be alternating. So next term would be your 3 by 5 whole square x minus of your 3 by 5 whole cube x, and this will go on till infinity. Okay, that's a better option, I guess. We will not mess much with that power n minus 1 because that would bring pretty complications. Okay, this is much better. So guys, f of x is right in front of us, and I hope it will not be a very difficult task for you to evaluate this because this is a GP. So guys, if we evaluate like infinite GP, so x being taken common out will remain outside, and this is a GP with your first term as 1 and common ratio 1, sorry, not 1, common ratio as minus 3 by 5. So 1 by 1 plus 3 by 5 because it's a by 1 minus r, right? So 1 by 1 minus of minus 3 by 5. So this thing becomes 5 by 8x. Actually, if you have tended your limit and n is tending to infinity, your f of x would come out to be 5 by 8x. Like this is only for the condition where we are tending n to infinity. Okay, this expression that came out for f of x, it's very complex actually. If you apply other constraints, though nothing is mentioned actually, but manipulations could be, there are possible manipulations that could be done such that this becomes something else. Okay, it will absolutely come out to be something else. So you have to be pretty careful for that. Anyways, guys, I hope things are clear till here. So next on, let's go on into our g of x. So g of x was given to be limit n is tending to infinity, and this is x. Okay, I know my x and n look very similar, but don't get confused. This is your sigma n equals to 1 to n, 3 power of n minus 1 into sine cube x by 3 power n. So very simply guys, I hope you can understand what we need to do because there is a sine cube term here. We will try to express it in terms of, like this is sine cube theta. So we try to express it in terms of sine 3 theta. So this thing becomes a sigma n equals to 1 to n. Actually, I don't know if this is r equals to 1, but we will go whatever is given in the question. We will go with that. Okay, so this thing actually becomes 3 power n minus 1, and if we want to convert this into sine 3 theta terms, I hope this will be 1 by 4 into 3 sine theta, that is x by 3 power n minus of your sine x by 3 power n minus 1. Okay, I hope this is correct. Yeah. Okay guys, I actually said something wrong. I'm sorry, it's not sine 3 theta. Okay, it's actually we are trying to convert this into the form of sine theta by 3. I mean submultiple angles, right? It's not multiple angles, it's submultiple. Okay, because x by 3 power n is given, so if it was 3 power n into x, then we might have thought of multiple, but we are trying to convert it into submultiple angles. Okay, so I hope this is clear. And guys, after this what we will do is we will pull out the 1 by 4. Limit n is tending to infinity, sigma n equals to 1 to n. And let's do one thing, multiply this 3 power n minus 1 inside into the bracket. So this thing becomes 3 power n sine of your x by 3 power n minus of your 3 power n minus 1 sine of x by 3 power of n minus 1. Okay, so like after this thing, if we little bit start off applying this sigma to the terms in the bracket, let's write down a few terms. So just considering this bracketed part, this will actually become, first term is 3 sine x by 3. Next term will be your 3 power n minus 1, so 3 power 0. Sine of x by 3 power 0, so only sine x. And next term will be 3, I guess, square sine of x by 3 square minus of 3 power 1 sine of x by 3. Okay, yes, this is what I was actually searching for. So guys, this is coming into a telescopic series because this and this are getting cancelled. So if this and this are getting cancelled, actually this will also get cancelled, which means this is a telescopic series. So actually, you know, I hope you know this, from the first pair, because the second term is remaining, so all the terms will get cancelled, only the second term from the first pair and the last term, and from the last pair, I am sorry, the first term will remain. Okay, From the first pair second term and from the last pair first term. That's the how telescopic series works. So this will be 1 by 4. Limit of n is tending to infinity. Sigma n equals to 1 to n, and guys, we don't need the sigma. I'm sorry. Sigma is already evaluated, right? So this actually will come out to be 3 power n sine of x by 3 power n minus of sine x 3 power 0. So because this thing is done, so I hope right now we can straight away go forward to applying the limit. And one thing that you will right now see is that in sine x by 3 power n, in this particular sign, the argument of sine is going to 0. Which means that if we multiply divide with x by 3 power n, we can actually write this as 3 power n into x by 3 power n straight away. Okay. And this will be minus of sine x because it doesn't have any relation with the limit. So right now things are pretty simple. 3 power n and 3 power n get cancelled. So this thing becomes 1 by 4 x minus sine x. So your g of x has come out to be 1 by 4 x minus sine x. And for your reference, I will also write down f of x once. It has come out to be equal to 5 by 8x for n tends to infinity. Okay, this is almost our sum is towards the end because we have found out all the real stuff that is needed. So once this is done, it will not be a very difficult problem to solve. So guys, let's go on into our result. First expression that was there is limit x is tending to 0. There were two expressions. I am solving them one by one. So first expression was greatest integer function, and within that there was a modulus also. 24 g of x by f of power 3x, and also within the box function. Okay. So this thing becomes your limit x is tending to 0. And this will be within the modulus, I guess, 6 times x minus sine x, and because by f of x cubed, so x cubed, and this term would be, I guess, 8 by 5 whole cube. Okay, so no much work about the modulus, and obviously this is limit x is tending to 0. So if you see sine x argument will directly go on to 0, or you can also do one thing. Wait, what am I speaking? I'm sorry, I just spoke something wrong. For this particular part of the limit, directly apply one step of L'Hopital's. Okay, so this will come out to be 1 minus cos x by, I guess, your 3x square. And then it's done. A 6 is multiplied here. So 1 minus cos x by x square limit, it goes off to half. This goes off to 2, and 2 and 2 get cancelled. So everything is actually gone. Okay. Okay guys, I actually went a little off track and spoke a lot of shitty stuff, and that was all wrong. Okay, I'm really sorry. Sometimes mind stops working. Anyways, actually the main thing, this is a very easy limit. I don't know why I messed up so much. Just this is, I will directly say this is 2 steps of L'Hopital. Okay, very easily. I don't know what I was randomly speaking and all. This is very simply 2 steps of L'Hopital, and immediately if you apply L'Hopitals to this, the final result that would come out will be 1 by 6. Okay, it would actually be, I guess, in the end, limit x tends to 0 cos x by 6. So this would come out to be 1 by 6. Okay, I am really sorry for the inconvenience because I spoke a lot of wrong things there. So this actually becomes 6 into 1 by 6 into 8 cube by 5 cube. So if you evaluate this, 6 and 1 by 6, obviously they get cancelled, and this thing would become 512 by 125. Okay. So basically it's the greatest integer function. So 125 into, if I see 5. I guess it's 625. So obviously 125 into 4 is approximately, I guess, 4 to 8, 9. Okay, 125 into 4 is 500. So that's the closest one, and it will be obviously 4 point something. So this comes out to be 4. Okay, that's the first part that was given in our expression. And the second part that is given is limit of x is tending to 0, 1 plus g of x power 1 by f cubed x. Okay, so this is a little bit giving a feeling of 1 power infinity. Anyways, let's see. This will be limit x is tending to 0, and inside will be 1 plus x minus sin x by 4, and above you will have this as 8 cube by 5 cube into x cube in the denominator. Okay, so this is like if we apply x is tending to 0 right here, I guess this is coming, yes, it's a 1 power infinity form. This was very clear actually. Such forms are always 1 power infinity forms. Okay, anyways, so this will be actually e power of your limit x is tending to 0, and we know there is a minus 1, so this 1 will get cancelled. X minus sin x by 4 multiplied by 8 cube by 5 cube x cubed. So if we evaluate this somehow, I guess it's actually coming to be like very similar to the last one, right? If I rearrange this, this is actually e power limit x is tending to 0. Yeah, it's the same limit actually we evaluated just a while ago, into your 8 cube by 4 into 5 cube. So actually this part is your 1 by 6, right? We evaluated this just a while ago. So this would actually become, if we do a little bit manipulation, e power 1 by 6 into 512 by 125 into 4, I guess. Yeah. So this is coming out to be, if we evaluate, e power, I guess 6 and 512, right? 64. And also one 4 cancellation would be there. And this is, I guess, becoming 375. Yeah, so kind of our answer is absolutely ready. We had ohm equals to limit x is tending to 0, the sum of these two limits. So ohm is equal to 4 plus e power 64 by 375. And actually we were asked the sum of all these terms. So 4 plus 64 plus 375, which is 68 plus 375. So if I just do a little bit of rough work and add this, 375 plus 68, this is 8 plus 5, 13, 1 plus 7, 8 plus 6, 14, and 1 plus 3, 4. So your final answer for this question is 443. Okay, so I hope you have liked the question, guys. Like, this was a really super question. Okay, that, like, the most important step in this particular question, this limit that was given, maybe you can solve, but the most important step in this question was evaluating that f of x that I did at the top. Okay, that is like something that many people might not be able to understand when they are inside the exam hall. Okay, and this is something that JEE Advanced hasn't still used. This was used much in the, like, IIT JEE papers when they were there. Then it was much used, but right now this has not been asked for a couple of days, so you can expect this to come sometime. Okay, anyways, that's it for today, guys. I hope you have liked this video. If you have liked my channel, do like, share, and subscribe. Any recommendations, comments, doubts, anything, do come in the comment section, or you can even message me on my Telegram. And do join my Telegram broadcast group, because I have been posting a real lot of relevant stuff there, and I hope you will like it. Okay. Anyways, that's it for today, guys. That's the end for this video, and thanks for watching.